Hey guys, it's Mrs. Antos. Welcome back to school. Hope you guys had a really great break, a nice Easter, even though I'm sure it was different than what you're used to. Today we're going to focus on everything we've learned thus far in Chapter 9. And we're going to do a little review together. And Wednesday, you're going to have a quiz. So now for the quiz is going to be very similar to what we're doing today. So if you understand what we're doing today, you'll understand what we're doing on the quiz. The quiz is going to be one of those Google quizzes where you can see your results right away. So make sure, before you hit submit, because once you hit submit, you won't be able to come back and change it. I'll make sure to put that in my directions. But once you hit submit, it'll grade it automatically for you. And you can see your results right away. Okay, so that's going to be on Wednesday. You are allowed to use a calculator. You're allowed to use your notes. So make sure you take advantage of those kind of little opportunities that are coming due to being at home, okay? So the first couple of things we're going to look at is just how to work with square roots. So those were the first couple of sections that we covered. So a square root, if it's a perfect square, you can find a number times itself when you take the square root of a number. Doesn't always work out that way. Not every number is a perfect square, so sometimes you'll have to use your calculator. So keep that in mind as we go along. Okay, so the very first question, we are going to solve, oopsie daisy, we are going to solve for a. So I have a squared equals 144. I can't solve for a the way it is because it's a squared and not just a. So to solve for a squared, to solve for a, we're going to take the square root of both sides. Okay, so the square root of anything squared is just itself, so that gives us a, which is what we want. And then now we take the square root of 144. This happens to be a perfect square. If you're not sure, you can refer to the chart that I gave you, or you can use your calculator. Don't forget, when you're taking the square root of something, it's always going to be plus or minus because it could be positive or it could be negative. So the square root of 144 is plus or minus 12. Easy peasy. Okay, sorry, Mr. Antos's computer is making weird noises in the background, so just ignore it. Okay, second one. This one's a little more complex. So I have 9w squared equals 225. Oh, by the way, you should be taking notes on this stuff, okay? When you take notes, you have something to refer back to. You also can, sometimes it ingrains in your head a little better. Okay, this actually has one more step than this previous problem. Here we just had a all by itself. Now we have a 9 in front of our variable. So before we take any square roots, we're going to need to divide 9 on both sides. When we do that, we get w squared equals 25. Again, you have your calculators, so feel free to use them. Because I'm running out of room, I'm just going to do the next step right in this line, but you're going to take the square root of both sides, and you get w equals plus or minus 5. Again, 25 is a perfect square. If it wasn't a perfect square, you just plug that 25, or let's say it's 26, the square root of 26, you plug it into your calculator, and you'll get an answer out of it, okay? All right, so that's solving when you have a variable that's squared. Let's look at some other square root type problems. The other thing that we learned about square roots was simplifying them. So the next several questions, I'm going to ask you to simplify some square roots. Okay, if you remember, we had the product property, which means that you can multiply two square roots together. Excuse me. We also had the quotient property, which means we can split it up into a division problem. So keep that in mind as we go through these problems. Okay, the first one is the square root of 4/9. This one is really nice because it's pretty straightforward. We can use the quotient property which means we're going to split these up into the square root of 4 over the square root of 9. Both of these are perfect squares, so we don't even have to do anything further with this. Square root of 4 is 2, and the square root of 9 is 3, so our answer is 2/3. There's no need to divide this here and then put it in the calculator. These are all things you can do without a calculator. All right, let's pump it up a notch here. We're still simplifying. Now I have the square root of 48 over the square root of 2. So they're already separated into two separate parts. Okay, now I look at this and I say, oh boy, one of my rules is I cannot have a square root in the denominator. So I'm going to do what's called rationalizing the denominator. Do you guys remember that all the way back when? To rationalize, you're going to multiply the numerator and the denominator by whatever is down here in this denominator. Okay? So that gives us 48 times 2, which is, 96. So we have the square root of 96 in the numerator. And then the square root of 2 times the square root of 2, if you recall, the reason we rationalize this, it gets rid of the square root, and we're left with plain old 2. We're still not done, okay? Because this should jump out at you, and you should say, oh, that's a kind of a big number, so I should probably can simplify it somewhat. And we can. So what you have to do is think of perfect squares, like what perfect square can go into 96? Okay, so I'm going through my perfect squares. 1, of course. 4 goes into 96, but is there something bigger? What about 9? Nope. What about 16? Yes, it actually does. So this becomes the square root of 16 times the square root of 6, because, 16 times 6 is 96. Okay, and then we're going to put that over 2. All right, since I'm running out of room, I'm going to go down here. Square root of 16 is 4. I cannot take the square root of 6, so I'm just going to leave it as the square root of 6 and put it over 2. Now, this is where you have to be careful. When you get to this part and you've simplified everything as much as you can, you want to look to see if you can actually, quote, simplify fractions. So if you ignored that square root of 6 and you had 4 over 2, what would you get? 2. So we can actually simplify this further to 2 rad 6. And I'm switching markers, so that was not that great. Excuse me. Okay, a couple more simplifying problems. This is dealing with adding and subtracting radicals. So I have 4 rad 5 minus 3 rad 5. Now this is different. When you add and subtract radicals, this is different than what we did up here. In order to add and subtract radicals, you have to have the same number in the square root, which we do. So all we have to do is take 4 minus 3. We get 1 rad 5. And you know, in math, we really don't put that 1 there. So it's really just rad 5. And there you go, it's simplified. Okay, same thing here, except now we have multiplication. This is going back to this product rule that I talked to at the beginning. You can multiply these two numbers together because neither of these can be simplified. There's no perfect square that goes into 3 or 15 other than 1. So we can multiply those two together. We get rad 45. And then I know that 45, I can divide 45 by 9. 9 is a perfect square. So I'm going to break this down into rad 9 times rad 5. And I get an answer of 3, because square root of 9 is 3, rad 5. And that's my answer. Okay, so that's kind of nice little crash course, if you will, on square roots or reminders of what we did at the beginning of chapter 9. So now we're going to apply this knowledge that we have to triangles. We're going to apply it to some distances, things of that nature. So the next thing that we talked about was the Pythagorean Theorem. Okay, so I'm going to draw a triangle. And it's a right triangle. Okay, so what do we know about our right triangles? Right across from a right triangle is our hypotenuse, which represents C. The other two parts are our legs, A and B. Okay, for this particular example, I have A equaling 24 centimeters and B equaling 18 centimeters. All right, so now that I know all this information, I'm going to plug this into my Pythagorean theorem, which is a squared plus b squared equals c squared. Okay, I've already labeled everything. So when you get a problem like this, label it. And then you can just plug your numbers in and use your calculator. Okay, so we have 24 squared plus 18 squared equals c squared. Again, you would use a calculator for this, but just to save time, I'm going to go ahead and plug the numbers in. 24 squared is 576. 18 squared is 324. That equals c squared. When I add those two together, I get, ooh, look at that, 900 equals c squared. That's going to come out pretty because, excuse me, when we take the square root of 900, we get 30. So C is equal to 30 centimeters. So that's kind of, I would call like the straightforward Pythagorean. There's another one that's maybe a little bit more challenging, where you have one of the legs, but not the other. And then you have the hypotenuse. So there's a little more manipulating with the formula for this one. We don't know what B is, but we know A and we know C. So again, if you're not sure, label those guys. This has to be C because it's the biggest and it's right across from the right triangle, okay? Or the right angle, my bad. So again, start off with your formula. A squared plus B squared equals C squared. Plug what you know. We know A is 10. So we have 10 squared plus b squared equals 26 squared, because our c is 26. Use your calculators. 10 squared is 100. You should know that one, hopefully without a calculator. But 26 squared is 676. We're going to subtract 100 on both sides, which gives us b squared equals 576. You're going to take the square root of both sides, and I'm just running out of room here. And that's a perfect square. That comes out to b equals 24 inches. Okay, so it's Pythagorean theorem there for you. So we need to use the knowledge of our square roots that we did in the previous problems in order to do this kind of stuff when you have Pythagorean theorem. Same thing with distance formula, which we'll get to in a minute. All right, numbers 9, 10, and 11. 9, 10, and 11. All I want you to do is tell me if the number is rational or irrational. So this will be multiple choice on your quiz. For something to be rational, you either have to be able to put it as a fraction, or you have a decimal that ends, which means it's terminating, or it could be a repeating decimal, okay? If it's irrational, it never ends, right? The decimal goes on forever. It never repeats. You can't write it as a fraction, so that would be like pi, for example. So let's take a look. Number 9, I have the number 4/9. Guess what? It's already written as a fraction, so this is going to be a rational number. We don't even need to think about it. Okay, number 10, square root of 289. This you wouldn't know probably without using your calculator. When you use your calculator, you find out it's a perfect square. Okay, and that means it's rational. Excuse me. And then finally, square root of 11. Again, if you were to use your calculator, that would come out as a long repeating decimal or non-repeating decimal. It's going to be this weird kind of looking number. Therefore, this is going to be irrational. Okay, so when you do that on your quiz, that's just going to be multiple choice, rational or irrational. Use your calculator. Refer to the notes in the definition if you're not sure. Okay, don't squander those points. Those are easy points. Okay, next one, and these are the last. I've got 2 more problems for you. These are the last 2. The first one is the distance. I want to find the distance between 1/6 and 4/10. Okay, before you do anything, you need to know the distance formula. Okay, so the distance formula is really long and annoying. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. That means I need to label my points. Okay, before I do anything, this is all prep work, writing the formula, labeling the points. This is x1, y1, x2, y2. So use that info, plug it into your formula, and the rest is a piece of cake. So you have 4 minus 1 squared plus 10 minus 6 squared. Sorry, Mr. Antos' computer is really going crazy. When you go ahead and do the math, so to speak, 4 minus 1 is 3, so you have 3 squared plus 10 minus 6 is 4 squared. 3 squared is 9, 4 squared is 16. When you add those together, 9 plus 16 is 25, and that actually works out really pretty. Our distance is 5. Okay, so for distance, make sure you're just you're copying the formula correctly, you're labeling the points correctly, and it's a surefire way of getting the right answer. Okay, last problem I have for you guys to review is midpoint. Okay, so think about the word midpoint. Mid means the middle or the average, the mean of 2 numbers. Okay, point means it's a point. So we always represent points by doing an X and a Y, right? Your answer has to be in the form of a coordinate point. If it isn't, it's not right. Okay, so last question here, we're going to find midpoint of -6, 2 and -4, -2. If you didn't have your notes and you couldn't figure out, oh my gosh, how do I do the midpoint? Talk it through. It's the middle or average of 2 points. So I got to find my average of my x's. So I take x1 plus x2. There's 2 numbers, so I'm dividing by 2. That's part 1. Then I'm going to take the average of my y's. y1 plus y2 divided by 2. That's the formula. Again, we want to label our points. x1, y1, x2, y2. That's how we, make sure we're not making mistakes. So I have -6 plus -4. Watch your signs. Okay, and then I have 2 plus -2. divided by 2. Okay, negative 6 plus negative 4 is negative 10. So I got negative 10 divided by 2. And then 2 plus a negative 2, that's the same as saying 2 minus 2. So it's 0 over 2. I want to simplify these, and I get negative 5, because negative 10 divided by 2 is negative 5. 0 divided by 2 is 0. Okay, so that's it in a nutshell. Those are all your types of questions that you'll have on your quiz on Wednesday. If you have any questions, please reach out. I'll be happy to help you guys. All right, so if not, find some problems in the books, in your book to practice, and you should be fine. All right, have a good one.